Hey everybody, this is Alex Merced from alexmercedcoder.com, and in this video what I'm going to do is talk more about Rust and talk more about the different collection types in Rust as far as collecting information. You've kind of seen arrays a little bit in the last couple of videos, but there's more. There's arrays, tuples, and vectors. And tuples you might be familiar with from Python, and vectors, if you've done any functional languages like Clojure, you might have seen vectors there. But they're actually all fairly useful here in this context. So arrays are pretty standard. So like arrays, literally the syntax is just like this. Like, of course, you can always type it as well. So if I want to type that, I could just be like, okay, integer or 32-bit or something like that. And that's all fun and good. The thing about arrays is that they're fixed length. So basically, since this has 5 spots, I can never make it have more than 5 spots or less. It's just a 5-spot array going forward. And again, things are just naturally sort of immutable here in Rust. But what if I wanted to have a collection of different types? Okay, then I would do a vector. So it would be something like this. It would be like I32 bool. Okay. And then what I would do, actually this would be a tuple. Okay, and then I would do something like 5 false. Okay, and then we will just do this, run that, see if that would work. Should. I'm just running. Nope. Let's see. No method named either found in a tuple. Got it. Okay. So in that case, what we will do, I'm gonna get rid of that. Do print. Okay, and we're gonna first print y0 semicolon, and then we'll just do that again. We'll just access both properties. So the first item of y should be 5, and then false. Let's see if that works. Let's see here. What is it like? Help to access tuple elements. Use y.0. Okay, it's dot notation for tuples. See, I really do like the errors in Rust. They're really good. Okay. So tuples, you access the properties through dot notation, not through brackets. Oh, that looks like it's doing the thing. Yep, and there you go. See, 5 false. So I'm able to store multiple items in one data structure, and they can be of different types. That's the beauty of a tuple. Tuples will also be fixed lengths, like arrays. So the big difference is arrays is going to hold all the same type of information. Tuples can hold different types of information. Now vectors, on the other hand, can hold a variety of types of information. And they're not fixed length. So I could do something like this. Okay, so a vector would be like this. I would just get rid of this here. And we're going to say let, and this would be square brackets again, 5 false, and then we would just use this macro, vec. And what that should mean is that create a new vector, and then this would be the contents of that new vector. Let's see here. Okay, and I do think vectors have to be of the same type, so let's make this a 6. Wait a second, let oh, that's right, this is here. And I think this comes back to being treated like an array. 0, 1. Yep, there we go. And you get 5, 6. Okay, so that's how a vector works. And again, with a vector, it has also some methods so that way you can remove items, shrink it, grow it. So vectors can actually have sort of variable sizing. So if you need an array, kind of like the way arrays work in JavaScript, that can grow and shrink at will, the vector is sort of your vehicle. And one last vehicle for collecting data is a hash map. Okay, so to create a hash map, what we're going to do is we would sit there and say let y, and it's going to equal a hash map new, and this is just a key value pair. So there's the hash maps created. Then we have to add some values. So we would do y.insert, and we'll insert, and then it's a key and a value. So we'll say name Alex Merced. Then we'll insert another thing, y.insert age 35, and then here we would do y.get, and we would get name, and then here we would do y.get, and then we would do age, and then we put some new lines here. There we go. Unexpected token, print. Oh, forgot semicolon right here. Okay. Use of undeclared type. Huh. See if I spelled hash map right. Okay, so the issue is that technically a hash map is from this library, but I think because I'm using REPL, I don't have access to just import it like this. I have to do that back in like on my computer where I have Rust installed. But yeah, essentially this would be how it works. You would create the hash map with this function here. That would assign a new hash map to this, and then you can insert keys and value pairs, and then you use the get function to get them, and that would pretty much be it. Cool. So we'll let that go. Let me get rid of this for the moment. Okay. Now let's talk about functions real quick. Creating a new function is pretty straightforward, because I mean literally this is a function definition, the main function, your main program. So that kind of already tells you what the syntax is for making a function. So if we wanted to create like a function that says hello world, it's simple as this: print hello world. Let's get rid of all this and then use the function hello world, and let's see if it works. Oh, as usual, it doesn't like the way doesn't like my conventions. There we go, hello world. It wants me to snake case everything. Okay. There you go. So see, the function works. And then again, I can have it pass in data. So I can be like, okay, I want it to have a string. Let's try this. A string that is hello. Okay, and instead what's going to happen here is we're just going to have the placeholder and a new line, and then you will pass in hello. Okay, so in this case, I will pass in the word hello world. Let's see, what is it like? Expected 1, found hello. Oh wait, I should probably typing is gonna work like it works for everything else, where I do colon. So it's gonna be like colon at stir. Let's try that. Yep, there we go. So there I can identify parameters, just like functions in any language, and then a return value would be specified like this. So if I want, let's say I want to specify a return value instead, so at string, okay, that would be the return value. So it's basically I'm saying, hey, I want it to return at string, so let's get rid of this, and we'll just say return hello. So it literally just passes right through. So in that case, let's do this. We're gonna print some stuff, and again we gotta put the little placeholder thing with the new line, and then what we're gonna place in that placeholder is the return value of hello world, passing goodbye world as an argument. So goodbye world gets passed in, that becomes hello, the function returns hello, and that's that. See, goodbye world. But if I try to put in the number 5, it's going to throw me an error because I specified that the return value should be a string, and well, the parameter should be a string too. So basically, both of them are gonna cause me an error because it doesn't match the typing. So he says like, see, it's expecting a string. So that's a function. Okay, you can have fun with that. Cool. So now in Rust there is no classes. So the way object-oriented programming works is a little bit different. The way it works is that you create what's called a trait. Okay, so let's see here. Let's create an example. So let's say I created a trait called hello. And basically what the trait hello includes is going to basically define what kind of a function that hello includes. Okay, so basically is this. We're going to say trait hello, so that's the trait we're creating. And then we define sort of the function signatures that this trait includes. So we're going to say that this trait includes a function called show, okay, which gets passed in itself. So basically the target of the function gets passed in that, and we're going to say that it returns a string. Oh, not show. I want to say hello. And actually, hello world, because I want to just use the function I've already created. Hello world, and that returns. And actually, I want to have it return at string because I want it to have the same signature as this function right here. Okay, and this would need an additional parameter. Okay, which would be hello, which is going to be the string, and then I need to add the parameter here because this function needs to be prepared to take itself in. Okay, add self. Okay, cool. So now those two have the same signature. Okay, so here's the function. But to make this a function that is of this trait, I have to do an implementation. So that way I attach it to a type. So we'll say that we're going to implement show. Okay, and actually what I'm going to do is I'm going to create a struct. So struct person. Okay, and the struct will just be empty. No particular properties. The point is just that we have a struct. So we can create objects called people now. Okay, implement. So we're going to implement hello world or hello for person. So now person is going to have access to this hello function. That's what the implementation does. Okay, and then we have to define the version of the function that works for the person. So basically I'm just going to cut and paste this in here. Okay. Cool. So we have a struct called person, trait hello. So now I should be able to create the new person. So we'll just say hello. We'll just say const or no let Bob equal person. There's no definition. There's no properties that Bob gets. So there's that. And then we'll just say Bob can then use hello using dot notation. Hello. And it's hello world. And we pass in hello. Okay, and then let me just get rid of this print line, and I'm going to modify the function so it prints something again. Print. There we go. And I think we are good. Let's run this. Okay, we got some errors. Let's take a look. But data from hello is returned here. Yeah, it's complaining that I haven't used it. That's fair enough. and the return type are declared with different lifetimes. Okay, so here's what we're going to do. I'm going to just say this doesn't return anything anymore, because we don't need it to return anything anymore. So let me just change the signature over here in trait. Do you mean person? Okay, I think let me do curly brackets over here. Okay, method not found in person. Let's see here, we did implement hello for person. That should make the function available. Okay, so I fixed it up. Mainly a bunch of missing semicolons. So since I created an empty struct, this is the syntax for an empty struct. So I created a person struct, and again, a struct is just a collection of properties. Okay, so basically it's like a class without methods. So basically the way Rust handles it is a lot like Go, where you create structs and then you can implement functions on those structs. Okay, one of the bigger differences is that Go has interfaces where you can create groups of functions to type things, while here you're using traits, kind of like in the same way you use interfaces, except they could have, usually they're like one function traits. So you're testing them by like a particular function or something. Okay, so here's a trait. So trait hello. Okay, so then we're saying this trait of hello, which means a function called hello world, we're going to implement that on person. Okay, so technically we are creating a type called hello that we could use for type checking. And then any struct that implements hello would then be able to pass that type check. Implement hello for person, which just means any person I create can then use hello. So bob.hello world, hello. Let's see, it works over here. Okay, so for example, if I wanted to create an array of, so say, hey, person array, which is going to be a type of at hello, which means, and I think I need to do this here. So it's going to be, the components have to be of type, meaning they can implement hello. I can then just do this, one new person, although this is going to error out because I'm probably not going to use this variable. So it's going to give me an error saying, you haven't used this thing. And I probably need a semicolon too. Hello, person.r, unexpected token. Okay, point is, when you type the array, you could type it based on the trait it implements. So then let's say I had different things I could implement. Hello, persons, parrots, whatnot. I could put them all in the array, even though they're different types, because they all have the same, they all implement the same trait. So it allows you to do some sub-typing in here. I'm not going to play around with it too much at the moment. Maybe in an upcoming video we'll play more with this. But this is basically how you would do object-oriented programming in Rust. So you don't have classes. So it's very similar to Go, where you have structs, and those structs can have functions implemented on them. And then instead of interfaces, you have traits. But overall, kind of the same idea. Slight differences, but overall the same sort of structure. So my name is Alex Merced from alexmercedcoder.com. So in this video, we learned about vectors, tuples, arrays, hash maps in Rust. We learned about how to write functions, and we learned a little bit about how to do OOP with traits and implementations in Rust. Have a great day and enjoy.